Okay, this is another practice or example. Okay. So example dia, a current carrying wire a length 1.6 cm between the pole force of a magnet perpendicular to the direction of magnetic field there. If the current in the wire is 24 ampere and magnetic field strength of 0.7 Tesla, what is the magnetic force on the wire? So the answer is, kita guna equation ini je lah. Sin theta. Okay, jawapan dia adalah 0.03 Newton. Okay. Okay. Okay, actually, okay, the magnetic field, okay, magnetic field yang produced by current carrying conductor, there are three types. Okay, they can divide into three types of current carrying. Okay, current carrying conductor, which is first the long straight wire, the current loops, and the solenoid. Okay, the long straight wire tadi yang kita bincang sebelum inilah long straight wire. And second, we go to current loop, and nanti kita akan tengok kepada solenoid. Okay, okay, ini adalah contoh. Okay, contoh yang ini adalah long straight wire. Ini adalah current loops, and this is the solenoid. Alright. Okay. The magnetic, kita masuk dalam long straight wire dulu Okay, long straight wire. The magnitude of magnetic field at a distance r from a wire carrying a current of I is, we can determine the magnitude. Okay. B equal to mu naught times I over 2 pi r. Ini kita sudah jelaskan tadi. Okay, kita sudah terangkan tadi bagaimana equation ini kita boleh dapatlah melalui long straight wire. So I dalam unit ampere, so R in unit meters. Okay. If, okay, kita pergi pula apabila magnetic field yang wujud pada two parallel conductors. Okay, kita tahu two parallel conductors or conductors ini dia carrying the current. Okay. Alright. As we seen here, okay, magnetic force act on current carrying conductor when the conductor is placed external magnetic field, because a conductor carrying a current creates a magnetic field around itself. Okay, so dia dia akan mewujudkan satu magnetic field around itself. It is easy to understand that two current carrying wire placed close together exert magnetic force on each other. Okay, let's consider two long straight wire. Okay, consider two straight wire, parallel wire. Okay, and separated by a distance r. Okay, we have two wire. Okay, and they are disparate with distance r and carrying currents I and currents B. Okay, sekejap, saya tukar ni dulu. Okay, kita assume kita ada dua. Mana sudah? Okay, kita ada dua wire dan dia membawa, masing-masing membawa current I and current 2. Okay, dalam in same direction. Okay, wire 1, okay, wire 1, this is wire 1, is directly above wire 2 with the so what the magnetic force on the on one wire due magnetic field set up by the other wire. Okay, in this calculation we can finding the force on wire 1. Okay, okay, we can okay, we can find the force on wire 1 due to magnetic field of wire 2. Okay, the current I, okay, the current I2 set up magnetic field B2 at wire B. Okay, faham tak? Maksudnya, the magnetic field, okay, the current 2 ini dia akan set up, okay, the magnetic field B2, dia akan menghasilkan magnetic field B2 pada current wire, pada wire 1. Okay, the direction of B2, okay, B2 is perpendicular to the wire as you can see here. Okay, so calculate the magnitude of magnetic field. So how to we calculate? Okay, kita tahu B2 equal to mu naught I2 over 2 pi D. Okay, so because 2 pi R sebelum ni kan, tapi oleh kerana dia disparate with D, yang R itu pada single wire saja. So sekarang ini kita tengok pada dua wire, okay, dua wire, parallel conductor. So 2 pi D, okay. Remember that the magnitude of the magnetic force on the wire 1 in the presence of B2 due to I2 in this equation. Okay, jadi force yang wujud pada B1 equal to B2 times I1 times L. Let's substitute our expression for B2. We substitute saja B2 ini. Okay, B2 ini pergi kepada di sini. So, we can rewrite. Okay, kita boleh rewrite kita punya equation as shown here. Ini. Okay. Okay, kita arrange dia balik. Okay, B2 ini tadi kita masukkan di dalam ini. Okay, yang ni tadi, B1 ni kita masuk dalam sini. So, you will get this equation. Okay, the direction of F1 is downward. Okay, toward wire 2 as you can determine by using right hand rule number 1. Okay, this calculation is completely symmetric, which means the force F2 on wire 2 is equal to an opposite F1 as we expect from Newton's third law of action and reaction. Newton's third law say they are action and reaction. Okay. So, ini adalah definition of ampere and definition of Coulomb. Okay. Ini another example. Okay, sila buat untuk example. Okay. Okay, kita pergi kepada magnetic field of current loops. Okay. Let's think about how to increase the strength of magnetic field due to a current carrying wire. Okay, one way is to form the wire into a loop. Okay, let's see how it's work. Okay. Okay. Actually, you can verify the direction of B by using hands rule number 2 for a long straight wire. Okay. Bayangkan you hold the wire with your right hand, with your thumb pointing on the direction of the current. Sama ada dia di atas atau di bawah lah. Okay. Your fingers then curl around in the direction of B. Maksudnya yang 4 jari kamu itu dia akan menunjukkan direction of B. Okay. Okay. The strength of magnetic field produced by a wire can be enhanced by forming the wire into a loop. Yang saya kata tadi lah. The small segment of the bottom of the loop labeled delta X1, okay, produce a magnetic field of a magnitude B1 at the loop center directed upward. Okay, ini sebagai contoh. Okay, all the segment delta X, okay, delta X contribute the magnetic field, increasing the strength. Okay, alright. Notice that the magnetic field lines enter the bottom of the current loop and exit at the top. Okay. Compare, coba kamu tengok di sini. Compare this figure, okay. Compare this figure, okay, figure below, which show the field of a bar magnet. Okay, this look kan, yang ini adalah bar magnet. Okay, the field to a smaller, okay, smaller, okay. So one side of the loop act as a north pole and the one side act as a south pole. Okay, ini north and south pole bila dalam bar magnet. Okay, bila dia macam begini, okay, the two field are smaller lah. Okay, field mereka akan lebih small, so dia tidak akan strong. Okay, berbanding seperti ini. Okay, banding seperti ini, field dia akan lebih strong sebab jarak mereka adalah lebih kecil berbanding the bar. Okay. Okay. This is the equation how to calculate the magnetic field of current loop and solenoid. Okay. The method of magnetic field at the center of a circular loop with a radius r and carrying current I determined by B equal to mu naught I over 2R ini for loop, and for the solenoid with n loops, okay, in the coil, this become B equal to n mu naught I over 2R. Okay. Now, let's imagine a long straight wire pula. Okay, straight wire, kita bend into a coil of several closed space loop. Okay, the resulting device is called solenoid. Okay, this device is important in many applications because it acts as a magnet only when it carries a current. Okay, bila dia hanya akan bertindak sebagai magnet bila dia carries current. Okay. Inilah. It is also known as an electromagnet since it acts like a magnet only when it carries a current yang saya kata tadi. One end of solenoid act as a north pole and the other one, okay, dia akan act sebagai south pole. Okay, inilah solenoid. Okay, pada solenoid, it have exterior and interior. Okay, di luar ini dikenali sebagai exterior dan di dalam ini sebagai interior. Okay, N is the number of turns per unit length, or N equal to N besar over L length of solenoid, itulah. Okay, N kecil ini number of turns, berapa turns dia, berapa banyak dia bergulung itu. Okay, alright. Okay. The magnetic field inside a solenoid increases with the current and it's proportional to the number of the coil per unit length. So ini remember the magnetic field inside a solenoid increase with the current and it's proportional to the number of coil per unit length. Okay. Notice that the field line inside the solenoid are nearly parallel. Cuba kamu tengok inside the solenoid nearly parallel or uniform space and closely together. Okay, as a result, the field inside the solenoid is strong and approximately uniform. Okay, cuba kamu tengok di dalam ini uniform. The exterior field, so kamu tengok pada yang di luar pula, exterior field at the sides of the solenoid is ununiform, so it much weaker than the interior field and opposite in direction to the field inside the solenoid. Okay, kalau kamu tengok direction of current ini dia begini kan? Okay, direction dia seperti ini, dan pada interior ini dia hampir dia strong. Okay, field dia strong. Okay, magnetic field dia lebih strong because dia lebih uniform or parallel berbanding the exterior ini dia tidak ununiform, so dia much weaker than interior field. Okay. Maksudnya magnetic field di dalam lebih kuat berbanding magnetic field yang berada di luar. That's why bila kita masukkan magnet di dalam solenoid, okay, akan ada bila kita connect dia dengan ammeter, okay, bukan ammeter, ammeter, so dia akan ada mengalami, kita akan nampak perubahan kita akan nampak ada current kan, ada current mengalir, maksudnya ada perubahan needle of the ammeter, so maksudnya ada current yang mengalir. Okay. Okay. Okay, interior, yang inilah yang saya terangkan tadi. So we can we can define the magnetic field. Okay, magnetic field di dalam solenoid itu sebagai B equal to mu naught times N times I. For exterior pula adalah B equal to mu naught times N times I. Ini is current over 2. Okay. Yang ni kita cerita tadi lah sebab kenapa. Okay.